So here we have a question that is all about differentiation from first principles. So that you will get no marks for just differentiating it. However, you should just do that anyway, so that you know dy dx here, you can just write it down that it would be 8x minus 5. We know that. So if you come up with something other than that, then you know you've gone wrong. Couple of different methods for doing this question, because you're trying to find the gradient at a point straight away. You'll see the mark scheme later, but what I would do is just go for the general dy dx by definition. First of all, writing down that definition. So let y equal f of x, and by definition the derivative gradient function is the limit as h tends to 0 of the change in y over the change in x. And we're taking our changing coordinate to be h away from x, a little bit away from x. So we start with that definition, keep this limit as h tends to 0 in the whole time until you are going to take the limits, and then we're going to write our function in. And we simply write the function 4x squared minus 5x with x as x plus h, first of all, and then minus 4x squared minus 5x. Then we, bit of algebra, multiply out brackets and simplify, still keeping this definition is the limit as h tends to 0. Be really careful at every point to be explicit in each of the terms. I can now see here my minus 5x and my plus 5x cancel. I've got actually a 4x squared there and a minus 4x squared that are going to cancel. But don't forget, I'm going to multiply that 4 over there. Now I've simplified that numerator as far as it will go, and I'm at the stage now where I can divide each term by h. So I'm still looking at this limit as h tends to 0. But I can write, my first term is going to be 8x, my next is 4h, and my next is minus 5. So now I need to write my statement about limits. So as h tends to 0, then this whole function, 8x plus 4h minus 5, tends to 8x minus 5. The h will tend to 0, 4h will tend to 0. So therefore, by definition, when I take that limit, dy dx is equal to 8x minus 5. I don't need to write that limit anymore, but I must write that statement above it first. Okay, and as we can see from what I already knew, that's what I was expecting my gradient function to be. Then to answer the question, so at the point P 2, 6, I've basically got x equals 2 and plug that in. Dy dx is 8 times 2, take away 5, 16 take away 5 is 11, 5 marks. Mark scheme. One of the methods that they suggest here is just using the x coordinate given straight off. Not my preferred method, but perfectly fine if that's what you are going to do. The second one would be my preferred method. Just be careful in this mark scheme, they've not made a big deal out of having this limit. It is a big deal. You do need to write it, limit as h tends to 0 on each of these lines, and you absolutely need this statement here, actually more than that. You need more than that. It needs a statement that does say as h tends to 0, what is happening to that particular function. 8x plus 4h minus 5 tends to 8x minus 5, therefore in the limit dy dx is equal to. So this mark scheme isn't quite as robust as the examiner's mark scheme is would be in the real exams.